To demonstrate that inner sphere electron transfer was possible, Taube designed a simple and elegant experiment. He mixed hexaamine chlorocobalt, so this is cobalt 3, which is a purple complex. Cobalt 3 is D6, and it's low spin, which means it is kinetically inert to substitution. So he mixed pentamine chlorocobalt with hexaaquachromium. So this is chromium 2, which is D4, and it's high spin, and thus it's labile. Okay, so when he mixed these, he observed in solution. So we observed that the chromium transfers the electron to the cobalt because we said that that was thermodynamically favorable. And what we get is pentamine cobalt 2. Now this would be D7 and high spin, and so it would thus be labile. So actually, in water, this cobalt loses all of its ammonia ligands because there's so much more water around, and it becomes hexaaqua cobalt 2+. But in solution, we found green pentaaqua chlorochromium 3. So this is chromium 3+, which is D3 and inert. So the only way that we could imagine the chlorine transferring from the cobalt to the chromium is if the chlorine ligand is transferred at the same time as the electron. So we imagine that when these mix together, we form a cobalt-chloro-chromium bridge. The electron can then be transferred from the chromium to the cobalt, and when that happens, the cobalt becomes labile and the chromium becomes inert. So the chromium keeps the chloro ligand because its ligands don't exchange really fast, and the cobalt lets go of the ligand because it's labile. Because both the starting cobalt 3 and the final chromium 3 are both inert, this is strong evidence that the chloro ligand can't come from anywhere except during the electron transfer. So this simple experiment with the presence of the chloro ligand on chromium at the end is strong evidence for an inner sphere mechanism.